Today we'll be talking about counting principles. When we refer to combinations, we're talking about a selection of objects from a group of n objects where the order is not important. So the combinations of n elements taking r at a time, we use NCR, which we discussed with binomial expansion, which remember is just n factorial over r factorial times n minus r factorial. Okay, so n is the total number of elements, and r is how many you are selecting. Okay, so if we look at our first example, notice that for each of the following, we are going to determine whether the problem is involving permutations, combinations, or neither. So we have 6 students running for student government, president, vice president, and treasurer. The student with the greatest number of votes becomes president, the second highest gets vice president, and the student who gets the third largest will be the treasurer. How many different outcomes are possible for these 3 positions? So because the candidate that receives the most, they can't be selected for both president and then vice president. So this is one in which order is important. So this one is a permutation. If we have 6 people on the board of supervisors for our neighborhood park, we have a 3-person committee is needed to study the possibility of expanding that park. How many different committees could be formed from the 6 people? Okay, so the order in which we select the people is not important, so this one is combinations. And let's look at our last one. It says Baskin-Robbins offers 31 different flavors of ice cream, each a different flavor. How many such bowls are possible? This one would be permutations. We're not going to select the same flavor twice. Take a minute and try the example you tried. Hopefully for letter A you found combinations, and for letter B you found permutations. Okay, let's look at our next problem. We have a 3-person committee is needed to study the ways of improving public transportation. How many committees could be formed from the 8 people on the board of supervisors? So is the order in which we select people from the board important? In this case, no. So we're just going to do 8C3. Now you can use the calculator directly from there. If you would like to use the formula, you can. 8 factorial, let's do, we'll leave it. 8 factorial, 3 factorial times 5 factorial. And we know the biggest on the denominator is a 5 factorial, so we can leave 3 times 2 times 1 and 5 factorial. 8 will count down until we get to 5 factorial, and then we can cancel out. And we know 3 times 2 is 6, so this actually gives us 56 different ways. Now remember to do NCR in the calculator. You would push the 8 first, you would push the math button, you would go over to probability, and you would select option 3, NCR. And then type 3, push enter, and it should give you 56. Now I would like you to try the example you tried. Hopefully you found 210 for the from a group of 10 positions. How many ways can 4 doctors be selected? And in our last example, notice we have a standard deck of 52 playing cards. It has 4 suits with 13 different cards in each suit. In order for the cards, if the order in which the cards are dealt is not important, how many different 5-card hands are possible? So because it states the order is not important, we're going to use combinations. So if we have 52 total cards and we want to select 5-card hands, I would type 52, click that NCR button in my calculator, 5, and push enter, and we should get 2,598,960. And that's it. Try the final example you try. Hopefully you found 1,820 for the number of 4 card hands that can be dealt from a deck that has 16 different cards. We finished the final lesson, the end.